Today we examine the structural transformation of a massive fallen log into a high-performance secret forest shelter.
Initial survey protocols determine the internal integrity of the timber to ensure the core remains viable for habitation.
Precision cutting begins by removing the outer layer of decaying organic material to reach the stable heartwood beneath.
Standard industrial waste management practices are observed as the primary excavation phase transitions into a controlled internal hollow.
The mechanical boring process utilizes a high-torque drive system to evacuate the inner fiber without compromising walls.
Visual telemetry confirms the absence of internal rot or parasitic infestation, which could jeopardize the shelter's long-term durability. Pressure-regulated hydraulic expansion allows for the removal of large timber sections while maintaining the structural exterior shell.
And finishing techniques are applied to smooth the interior surfaces, ensuring that the living space meets geometric specifications.
Dust mitigation is essential for the application of protective resins that will shield the wood from future moisture.
The application of chemical barriers ensures the log remains fire-resistant and impervious to the damp forest environment.
Capillary action pulls the sealant deep into the grain, creating a permanent bond that reinforces the natural fibers.
Accurate measurements are required to integrate industrial hardware into the organic, irregular shape of the fallen tree trunk.
The structural steel frame provides a rigid anchor point for the heavy reinforced door and the security mechanism.
Fasteners are driven deep into the timber to prevent the frame from shifting due to natural wood expansion.
Camouflage protocols dictate that the exterior of the door must perfectly match the surrounding bark of the log. Biological concealment techniques involve the application of local flora to the door to mask any industrial thermal signatures.
From a distance, the shelter is indistinguishable from a standard fallen tree, maintaining total visual and structural secrecy.
Space optimization is achieved by excavating a secondary subfloor level designed for the storage of long-term survival supplies.
Thermal regulation is maintained through high-density insulation panels that prevent heat loss during the extreme winter forest months.
The wood stove provides a sustainable heat source while utilizing a filtered exhaust system to minimize visible smoke.
Exhaust gases are diverted through a camouflaged venting system that disperses heat to avoid detection by thermal imaging. A self-contained electrical grid provides power for internal lighting and communications through a discrete solar energy collection array.
Recessed LED lighting ensures low energy consumption while providing a high visibility environment within the dark wooden interior space.
Modular furniture design allows for the multifunctional use of limited floor space within the cylindrical interior cabin layout.
Suspension sleeping systems maximize the available vertical space while keeping the occupant away from the cold floor surface.
The integrated water management system processes raw rainwater into potable liquid through a multi-stage ceramic filtration process. Ceramic filters remove 99% of bacteria and particulates, ensuring the safety of the internal water supply line.
Acrylic observation ports are placed strategically to allow for external monitoring while remaining hidden from casual outside observation.
Rigorous waterproofing tests are performed on all hull penetrations to ensure the shelter remains dry during heavy storms.
Steam-bent wooden shelving conforms to the natural internal geometry of the log, providing secure storage for dry rations.
A 3-month supply of nutrient-dense rations is stored within the pantry to facilitate long-term independent off-grid living operations.
Active ventilation systems prevent the buildup of carbon dioxide and humidity within the airtight seal of the shelter.
Fine mesh screening provides an effective biological intruders.
Internal communication systems are linked to a concealed antenna array located in the canopy of a nearby tree.
Underground cabling protects the signal line from weather damage and prevents visual detection by potential intruders or scavengers. Maximum signal range is achieved by positioning the antenna above the forest canopy line for uninterrupted satellite transmission. Safety equipment is strategically placed to address potential hazards, including fire or smoke, within the confined living environment. Emergency medical supplies are organized for rapid access in the event of an industrial accident or personal injury. Industrial rubber flooring provides a durable and slip-resistant surface that simplifies the maintenance of the interior cabin space.
Heat-shrunk seals protect electrical junctions from the high humidity levels often found in deep forest industrial settings.
Real-time data monitoring allows the occupant to manage resources and maintain optimal environmental conditions within the shelter. Solar efficiency is measured to confirm that the battery bank receives adequate charge even under heavy forest canopy.
A redundant power system ensures that critical electronics remain operational during periods of low sunlight or battery failure.
The final masking phase involves the artistic placement of branches and leaves to blend the structure into nature.
Thermal imaging confirms that the shelter is effectively invisible to infrared sensors.
The hydrophobic coating on the exterior surfaces prevents water absorption and protects the structural integrity during heavy rainfall.
The combustion process is initiated to test the efficiency of the drafting system and the heat distribution network.
Forced air dispersion breaks up the smoke plume to ensure it does not rise above the tree line.
The kitchenette is equipped with energy-efficient appliances that minimize power draw while providing essential food preparation capabilities.
Pressure-regulated water delivery ensures a consistent flow rate for cleaning and cooking tasks within the forest cabin. Magnetic tool storage keeps essential maintenance equipment organized and accessible without occupying valuable counter or shelf space.
Mechanical locking systems provide a secondary layer of security, ensuring the safety of the occupant from external threats.
Acoustic dampening materials prevent internal sounds from escaping the shelter, maintaining the secret nature of the forest home.
Field testing confirms that the shelter's visual signature is negligible, even when observers are in close proximity.
High-definition video feeds ensure that no movement around the shelter goes undetected by the onboard security computer.
Arai successfully recharges the main battery bank during daylight hours. Ongoing moisture monitoring is critical to prevent the growth of mold and to ensure the timber remains dry. This airtight construction is verified through a pressure test to confirm that the internal environment is fully controlled.
The specialized rescue and maintenance equipment is kept on site to address any unforeseen structural or environmental challenges.
Mechanical dehumidification maintains an ideal internal atmosphere for both the occupant and the integrity of the wood.
Waterproof storage solutions protect personal items from the high humidity and temperature fluctuations of the forest environment. Natural insulating materials like wool are chosen for their superior performance in cold and damp outdoor conditions. Variable lighting controls allow the occupant to adjust the internal ambiance while conserving battery power during evening hours. The completion of the living quarters marks the successful conversion of industrial materials into a functional home.
Thermoelectric fans utilize waste heat to circulate warm air throughout the cabin without consuming any electrical energy.
Routine maintenance of the heating unit is essential for monitoring fire safety and enjoying the visual ambiance.
Local wildlife activity confirms that the shelter does not disrupt the natural ecosystem of the surrounding forest. The onset of daylight initiates the solar charging cycle and provides a fresh assessment of the site's security. Self-sufficiency is demonstrated through the preparation of meals using on-site resources and stored industrial ration supplies.
Moisture management during cooking is handled by the high-capacity exhaust fan located directly above the food preparation area.
Access to the exterior is carefully managed to ensure that the entrance remains hidden during all transitions.
Sign cutting prevention involves the elimination of tracks or disturbances that could lead an observer to the shelter.
Periodic structural inspections ensure that the exterior masking remains securely attached to the main log body over time.
Clearing the exhaust system of carbon deposits is a mandatory safety protocol to prevent dangerous flue fires.
Hydraulic closing systems provide controlled and silent door operation, preventing loud impacts that could alert nearby observers. Navigational intelligence is maintained through high-resolution topographical maps, used for planning external patrols and resource gathering. Auxiliary equipment is integrated into the central power system to ensure all critical tools remain fully operational. Visual resource tracking allows the occupant to monitor water consumption and plan for the next rain collection.
Chemical treatment of waste products is necessary to maintain a sanitary living environment within the confined space.
Maintaining internal cleanliness prevents the accumulation of debris that could interfere with mechanical systems or air quality. The intersection of natural beauty and industrial engineering creates a resilient and aesthetically pleasing secret forest dwelling.